Chapter 1 Real Numbers Session 2. Let's start. Fundamental Theorem of Arithmetic. Fundamental Theorem of Arithmetic. Every composite number can be expressed or factorized as a product of prime, and factorization is unique, apart from the order in which the prime factor occurs. The prime factorization of a natural number is unique except for the order of its factor. Now what does it mean? For example, if I'll take 27 and if I'll find out the prime factor of 27, so those are 3 3s are and 3s are, right? You can never find this solution for any other number rather than 27. For example, if you are going to 32, so it is 2, 2, 2, right? 2 and 2. 2 2s are 4 2s are 8 2s are 16 2s are 32. So this is the unique representation or a prime factors of 32. So these numbers are unique. You can never find out those numbers uniquely, right? For example, if you take 64, so you can find out 2 2 2 2. It is not 5 times, it is more than 5 times, right? For example, if I write down 63, so it is nothing but the 21 3s are. 21 is nothing but the 7 3 and 3, right? So this is the unique factorization. So you can never find the same numbers 7 1 times and 3 2 times, right? So you can never find those combination. You can never find those combination, the same combination with the other numbers, right? Note. Now one note is there, HCF of AB and LCM of AB is nothing but the product of the AB, is nothing but the product of AB. Now what does it mean? So for example, A is equals to 4 and B is equals to 14. So what is the HCF of 4 and 14? So 4 is written as a 2 multiplied by 2 and 14 written as a 2 multiplied by 2 and 14 is 2 multiplied by 7. So HCF is nothing but the highest common factor, so that you already know. So HCF is 2. So what about the LCM? So LCM of 4 and 14 is nothing but the 28. How 28? So let's see how it is 28. So here 2 multiply by 2. Here one time only 2 is there, so we don't need to write. But 7 is not there, so multiply by 7. 7 2s are 14. 14 2s are 28. So LCM is nothing but the 28. Now HCF into LCM. So what is the HCF? So HCF is nothing but the HCF is nothing but the 2. So 2 multiply by what is the LCM? 28. So 2 into 28 is nothing but the 56. And 4 into 14. 4 into 14 is nothing but the 56. So we can say that HCF of AB and LCM of AB is nothing but the A into B. So this is we proved. So this result is true for any two numbers. This result is true for any given two numbers. Remember, this is true only and only for the two numbers, not for the three. Okay, it is true only and only for the two numbers. Now exercise 1.2. Express each number as a product of its prime factors. It is simple. 140. So how we can do that? We already did in standard 5. 140. 2s are 70. 2s are 35. 5s are 7. 7s are 1. So it's a 2, 2, 5 and 7. So 2 into 2 can be written as a square of 2. If you can write this down 2 square or not, that is fine, but you need to write down up to here. That is compulsory. Now 156. So you just go with the 156. So 2s are 7 and 3. 70. Sorry, it is not 73. It is 75 and 78. Right? Divided by 2. 78 and 2 are divided. So it is nothing but the 3 9. 39. Now 3s are 13 and 13 1. Okay, so here it is 2 2 3 and 13. 2 2 is nothing but the 2 square, so and 3 into 13. In the same manner you can go with the 3825. Now you know how to do it, so just do this sum by yourself. Okay, now let's move ahead with the another sum. Right, before that, so it is nothing but the 3 3s are 9, 9 5s are 45, and 45 17s are 3825. Right, okay, let's see here. No, you need to practice it by yourself. Now 5005, right, 5005 in the same manner, so it is nothing but the, let's see here, 5005, right, so it is nothing but the 5s are, so 1001, right, so it is divisible by 11, right, for sure. So it is nothing but the, now first of all it divided with the 7, so 7 1s are 7, 3 is remain, 37 4s are, sorry, 1000 divided by 7, so 7 1s are 7, 3 0 4s are 28, 2 1 and 3, 143, right, so it is nothing but the 143. Now 143, so 1 and 1 4, so it is divisible by 11 now, so 11 1s are 11, 3s are 13 and 13s are 1, right, so 13 11 7 and 5, so 13 11 7 and 5. Okay, so in the same manner you can do 7 4 2 9. The same manner you have to do for the 7 4 2 9. Right, now let's move ahead. Now find out the LCM and HCF of the following pair of integers and verify the LCM into HCF is equals to the product of two numbers that we already see in the very first slide, and that is HCF of AB into LCM of AB is equals to A into B. So this thing we need to prove. So 26 and 91. So 26 can be written as a 2 13s and 91 can be written as 7 13s, right? Just that we already know. We know how to find out the HCF and LCM. So HCF is nothing but the common number, which is common factors which is there in all the given numbers. So 13 is the HCF. So HCF is 13. Then LCM. So 13 2s are 13 is already there. So we already need to write down the 7. So 13 to the 26. 26 7s are 182. So we find out the HCF and LCM. Now product of two numbers. So that is 26 and 91. So 26 into 91 is nothing but the 2366. Now LCM into HCF. What is the LCM? 13. What is the HCF? Sorry, HCF is 13. What is the LCM is 182. So multiply these two numbers. You will get the 2366. So here we can conclude that product of the two numbers is equals to the LCM and HCF of the given two numbers. Hence the product of the numbers are the HCF into LCM. So the same sum, right, we have to do it for the 510 and 92. So 510, prime factors of 510 are 2 3 5 17 and 92 is 2 2 23. Now what is the HCF? What is the common number is only 2, right? There is no other common number, so HCF is 2. Now what is the LCM? So LCM is nothing but the 2 3 5 17. 2 3 5 17. Here 2 is 2 times, so we need to take 1 time more. So here it is, see here first, so it is a 2 3 5 and 17. So 1 2 is already there, but another 2 is not there, so we need to multiply here with the 2, and 23 is not there, so multiply with the 23. So this is our LCM. So here it is. This is our LCM. So LCM is nothing but the 23460 and HCF is 2. Now product of the two numbers is nothing but the 510 multiplied by 92 is nothing but the 46920. HCF into LCM is 2 into 23460 is equals to 46920. Hence the product of the number is HCF into LCM, because here it is 46920 and here is also 46920. And now after doing these two sums, the last sum is the self practice, that you need to do it by yourself. Now let's move ahead with the question number 3. What is the question number 3? So find out the LCM and HCF of the following integers by applying the prime factorization method. So prime factorization method, what is the prime factorization? So that we already know. We need to find out the prime factors of 12, and that is nothing but the 2, 2s are 4, 3s are 12, right? So 2 square into 3. Similarly for the 15, it is nothing but the 3 into 5, and 21 is nothing but the 7 into 3. So we need to find out the HCF. What is the common? So common thing is 3. The common number is 3. So HCF is 3. So what is the LCM? So 2 multiplied by 2 multiplied by 3. Here 3 is already there, so we no need to write down, but 5 is not there. Multiply by 5. Here 3 is there, but 7 is not there, so multiply by 7. So that is the LCM. So 2 square, 3, 5 and 7. So what is the LCM? LCM is nothing but the 420. So find out the LCM and HCF by the following integers applying the prime factorization method. So if you are asking that find out the HCF and LCM with the help of prime factorization method, it is very easy, that we already did in the standard 5. So in the same manner, you need to do the sum. Simple, right? Prime factorization nothing but this. It is 12, 2s are, 6s are, 2s are, 3s are, 3s are and 1s are. Okay. So these are the numbers 2, 2s are and multiply by 3. In the same manner you can do for the another number also. Now let's move ahead with the another sum, and that is 17, 23 and 29. 17 is a prime number, 23 is a prime number, 29 is a prime number. So each and every number is a prime number. So HCF, if all the numbers are prime number, then HCF is 1. HCF is 1. It is not the 0. Remember, it is not the 0. HCF is 1. Now what is the LCM? LCM is nothing but the product of the given numbers. So LCM is nothing but the product of the given numbers. That is 11339. This last sum is easy. You can do it by yourself. Okay. Now let's move ahead with the question number 4. So what is the question number 4? So given that HCF of 306 and 657 is 9. So what is the LCM? See, if this kind of a question is given, so you need to apply this formula. We know that HCF of AB into LCM of AB is equals to A into B. But here we have given A is equals to 306 and B is equals to 657. So HCF of 306 657 into LCM of 306 657 is equals to 306 into 657. So we know the HCF. HCF is already given, and that is 9. So here we put the 9. We need to find out the LCM. Now this 9 from the multiplication goes into the division, right? So now you simply divide it and you will get the 22338. So what is the LCM? So LCM is nothing but the 22338. The sum is that simple. You just remember the formula, put the values, do the simplification, and you will get the answer. Hence, the LCM of 306, 657 is equals to 22338. Okay. Now let's move ahead with the another question, and that is question number 5. Check whether 6 to the power n can end with the digit 0 for any natural number. For example, if I write down 6, n is a natural number, and natural number start with the 0. 6 power 0 is 1. 6 power 1 is 6. 6 power 2 is 36. 6 power 3 is 216. Right? So here you can observe that not a single digit can end with the 0, and if you do it for more, you will see that any number cannot end with the 0, right? If any digit can end with the 0, they have at least 5 and 2 as its prime factor. For example, 30, right? If you see the 30, it is nothing but the 3 into 5 into 2, right? If you can say 50, so 50 is nothing but the 5 into 5 into 2. So here 5 and 2 is there. In any number's prime factorization, if you find out the 5 and 2 as its prime factor, if you find out 2 and 5 as its prime factor, then you can say it is end with the 0. But here 6, 36, 216, right? So all the numbers are the 6, 36 and then the 6, 6 are 6, 6, 216 and then the 6 multiply by 6 multiply by 6. So here no, not a number. If you can prime factorize the 6 nothing but the 2 multiplied by 3. If you do the 2 multiplied by 3 power n, you will not find out the prime factor as a 5 and 2. So if you don't find out the factor as a 5 and 2, you can say it is not end with the 0. Now let's see step by step. If the number 6 power n for any n were the end with the digit 0, then it would be divisible by 5. See, for where to end with the any digit 0, then it would divisible by 5. That is, prime factors of 6 power n would contain the prime number as a 5 because 2 is already there. That is why. This is not possible because 6 power n is equals to 2 into 3 whole to the power n. So the prime in the factorization of 6 power n is 2 and 3. So primes in the factorization of 6 power n is 2 and 3. So the uniqueness of the fundamental theorem of arithmetic guarantees that there are no other primes factorization of 6 power n. So there is no natural number of n with the, here it is 6 power n, can end with the digit 0. Remember this, okay? It is simple. You need to remember the steps, what is written over there. So you need to remember those steps, but at the same time you need to do one thing, and that is if it is given 7 power n, so you just simply write down 7 into 1 to the power n, and here you cannot find out the factor as a 5 and 2, 5 and 2, so it is not end with the 0, right? That is the thing that you need to know, and this you need to write down this 3-4 times so that you can easily understood the steps what it means to say. I already explained, but still, okay? Now let's move ahead with the question number 6. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 can be a composite number. Now we have a co-prime number, prime number and composite number. So co-prime number we see already in the chapter number, okay, we see in the upcoming lectures, okay. So what is the co-prime number? See, for example, if I write down 15 and 16, right? So what is the common factor here? 1 into 3 into 5. This is about the 15. What about the 16? It is 1 into 2 into 2 into 2 into 2. 2 2s are 4 2s are 8 2s are 16. So here the common factor is not another 1. It is only and only 1. It is only and only 1. So the common factor is only 1. The common factor is only 1. That is why 15 and 16 can say as a co-prime number. Two numbers are a co-prime number if they have only a common factor as a 1. Then it is say the co-prime number. Prime number you already know, right? That 5, 3, 7, 13, 11. These are the prime numbers, right? which is with the number which comes into their own and the ones table. Then composite number. Composite numbers are nothing but the 15, 16, 8, 4. So how you can define it? It is nothing but the 3 5s are. So it is nothing but the 4 4s are. So the number which are not prime number, the number which are not prime number are the composite number, which comes into the table of more than one number. So here you see, take out the 13 common out of this. So 13 and 13 take out common. So here remaining is 7 into 11. Here nothing is there into, so that means it is a 1. It is 17 plus 1, 78. Now you simply see this is 13 into 17. That means whatever the number is, it is comes into the table of 13 and 78. It is comes into the 13 and 78. If you more go into the deep, factorize 78, it is a 13 6. So it comes into the table of 13, 13 and 6. If you more, 6 is nothing but the 3 2s are. It is also comes into the table of 3 and 2. So if it is comes into the more than one numbers table, then it is kind of composite number. So the given expression 13 and 16, 6 and a 13 as a factor. Therefore, it is the composite number. Simple, right? Now the same you can do in this sum, and that is take out 5 and 5 common. Right, 5 and 5 common. So what is remaining is 7 6 4 3 2 1, and here 1. So the multiply these numbers, you will get the 1008 and plus 1 1009. So 5 into 1009. So the number, whichever the number is, it is comes into the table of 5 and 1009. The given expression has 5 and 1009 as a factor. Therefore, it is a composite number. Simple. If it is because it is comes into the table of 5 and 1009. Now, question number 6. There is circular path around the spot field. Sonika takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose both start at the same point and at the same time. To go in the same direction, after how many minutes? After how many minutes will they meet again into the starting point? See here, minimum time is required here. Minimum time. You need to understand from the given sum that minimum what time is required to meet them, to meet at the same meet each other at some spot. So if it is minimum, then we need to find out the LCM, right? So prime factorization, sorry, the time they are meeting is the LCM of 18 and 12 minutes. So prime factorization of 18 is 233 and prime factorization 12 is 223. Now what is hence LCM of 18 and 12? So this is nothing but the 2 into 3 into 3. So one time 2 is there, but second time is not there. So multiply by 2. Here 3 is there. So no need to write. 2 2s are 4, 3s are 12, 3s are 36. So Sonika and Ravi meet after the 36 minute. Okay. So that's it for today. Let's meet into the next lecture. Till then, work hard. Bye bye.